Hello, so today I'm going to present the eMBMS, and first I'll go with a short presentation and then move to a demonstration. So just a little bit of context. Today we see that there is a shift. More and more critical communication network and public safety operators have a will to move from legacy networks to digital and broadband networks. And what we can observe is that traditionally the legacy networks are based on tetrapole, P25 networks that are proprietary networks with a one-to-many communication way, and those networks are limited to a push-to-talk feature. With the arrival of the 4G and 5G networks, we see that we have new additional features such as the video sharing and data sharing. And those networks are natively a one-to-one communication way. So at ENENSYS, what we're providing is a capacity for those new critical communication networks to scale. By adding the multicast feature, we are converting those one-to-one networks into a one-to-many networks. And the second very important point is that legacy networks are proprietary networks, while broadband networks are generally standardized networks using the 3GPP interface as defined by the standard. So just a quick schema to explain what the difference between unicast, broadcast and multicast networks. So into a unicast network, you're going to have a one-to-one communication between a speaker and a receiver. So for how many people you are going to have at the receiver, you're going to consume a limited part of the bandwidth. For broadcast networks, it's a one-to-all communication way, meaning that you have one speaker that is going to address to a whole bunch of people into the same area, but you cannot exclude some of those people. And in a multicast network, you can address into a single stream one message, either it's audio, video, or data, into a group of people and exclude some of others. So you're going to save a lot of bandwidth because by using only a single stream, you're capable to address a huge number of people at the same time. So in order to do some kind of comparison, the multicast can be seen as public transportation for bits and bytes. Indeed, in a unicast network, you will have plenty of cars into a crowded road with a single person into each one of those cars. And in the private network, you can have a very, very free road, but if you have plenty of buses, the road may be crowded as well. So the idea of multicast is to put everyone into a single bus and convey the bits and bytes into a single bus to the point where they are supposed to arrive. In that way, they have a very, very empty road and they will arrive perfectly synchronized at the same place at the same time. So when do you need to use multicast into your networks? There are several different possibilities. Either if you have a limited bandwidth, notably if you have a 3 MHz or 5 MHz band, then you know that you will need multicast because otherwise your network may be congestion. If you are having crowded cells with a lot of people into the same area, if you plan to have large group calls with more than thousands of people into a same group call, also if you are having different group calls with medium size at the same time, but if your will is to enrich your group calls with video or with data. A few examples, 3 examples to better explain how to use this multicast feature. The first one is a train crash situation where the commandant will ask assistance to the rescuer. So he's going to stream with his smartphone, he's going to make a live stream of what is happening, and the different rescuer can receive the live content to better analyze how they can intervene to save all peoples. Second example is a building on fire with firefighters sending a drone into the building, and the drone will stream the event for the firefighters to receive it and better analyze how they're going to intervene to extinguish the fire. And last is a crowded stadium where the different police officers need to be very, very well synchronized in their communication reception. And thanks to the multicast, they can be perfectly synchronized to receive the different information, for example, the picture profile of a suspect if there is any terrorist attack. So 7 reasons why multicast is a must-have. First one is the scalability. We have talked about thousands of people into a single group call. It can be very, very important to add multicast if you don't want your networks to be congestion. Second element is a robust reception. And third one is also linked to this one, which is a synchronized delivery. By having a single stream as a multicast stream to all users, you're ensuring a very, very robust reception and that all receivers will receive the message at the same time. You're also having a better and faster file download. Our KPIs are showing that it can decrease by 2.5 the time needed to receive a file. Spectrum efficiency, as you're also saving a lot of bandwidth in order to when you're using multicast. Same thing for the devices, where you're going to increase their lifetime by reducing the consumption, so their battery saving. And last but most important one is that you're really enabling MC data and MC video thanks to the use of multicast. In terms of architecture, at ENENSYS we are providing 2 pieces into the network. So we have what we call the multicast client, the MediaCast mobile, and a multicast server, the MediaCast mobile, and a multicast client, the Cube Agent. So in fact, we are going to retrieve the audio, video, or data from the application server, converting that stream into a multicast stream, sending the information into the network, into the core and the RAN, and then to the smartphones to receive and do the opposite, the conversion from multicast to unicast for the policeman or firefighter to receive effectively the message. So today the demo we're going to demonstrate is notably using those 2 different pieces, the server part and the client part. On the server side, we have an eBox, which is a private 4G and 5G networks, where we are adding 2 other pieces, a multicast server, the MediaCast mobile, and a MCX application server, which is here for our demonstration, the Cybertel application server. On the client side, we have 5 different terminals from Zebra, Crosscall, and Cybertel, and on those devices we are integrating the ENENSYS Cube Agent, the multicast client, and the Cybertel MCX application client. First scenario will be a unicast scenario where we're going to have one person speaking, and the different people will receive a video of that person, and the different persons at the receiver will each time consume a certain part of the bandwidth because it will be unicast downlink, so we are considering at approximately 600 kilobits per second, and in total for the 4 receivers we will consume approximately 2400 kilobits per second. Second scenario will be a multicast scenario where we are still having a unicast uplink for the person that's doing the video, and on the 4 people that will receive the video we're only going to consume one time 600 kilobits per second, where we'll have the multicast downlink that will address the same content to all people at the same time. So moving from 2400 kilobits per second to 600 kilobits per second, which is saying that with only 5 terminals we are going to divide by 4 the consumption thanks to the multicast feature. So here we are on the user interface of the eBox itself. So all the different devices have a private SIM card connected to the 4G private networks of the eBox. And here we have 2 graphics interested to watch. First one is the unicast traffic, and second one is the multicast traffic. So first scenario will be the unicast scenario, where I'm going to do a video call with the different terminals. And as explained in the slide earlier, we should see that we have an average of 2400 bits per second of consumption. Okay, so here again I have one smartphone that is speaking or sharing its video content, and all the different terminals are receiving in unicast the content stream. And I'm gonna do the exact same scenario but into a multicast scenario. So I'm going to switch the different terminals into a multicast group call. Okay, so let's move to the second scenario, the multicast scenario. So I've switched all the different terminals into eMBMS mode, where they joined a multicast group call, and I'm now gonna start a video multicast group call. Okay, so the different terminals should be well synchronized. When I'm moving my hand, they should all receive the same image or the same video at the same time. And regarding the average multicast traffic, I can observe I'm between 500 and 1 megabit of consumption, so approximately 600 kilobits per seconds of traffic, multicast traffic. So here I can really observe that the multicast traffic allows to divide by 2.5, 3, even 4 times the consumption compared to the Unicast traffic. So multicast is clearly a very, very important feature if you want to perform critical communication at scale.